Today we're in lesson 3 and we're looking at constant rate of change. And after we do constant rate of change, we're also going to learn about slope. The essential question today is, how are constant rate of change and slope similar to each other? So by the end, you'll be able to answer those things. Let's look at our first part of our notes here. I give you a nice chart here, and at the top of the chart, you see the words positive, negative, zero, and undefined. Down the sides of the chart, we have meaning, graph, and marble count over time. We'll find out what that is at the end here. So the very first thing I want you to notice is what we're doing in the margin. We are learning about the constant rate of change. And in this first picture here, we have a nice line that starts here, and it is very straight and it's moving upwards. So we're going to write the word up right here because it's going up. Now when it's going up, we say it is increasing rate of change. So it's moving up. In contrast, decreasing rate of change would be going down, and this one's going down. And so we'll write the word down. And then the next one is zero rate of change. It's not going up or down. You can see that it's going with no change. And we're going to call that flat. It's a flat slope. Another fancy word for a flat slope is zero slope. So we'll often say zero slope for our flat slope. And then the last one, the meaning of undefined, is exactly what you see here. It's an undefined symbol. Another way to write this would be a circle with a line all the way through it. That means undefined. The undefined one is also straight, but it goes vertical. So we're going to write vertical. Now, very shortly, in about a week, I ordered a new pen, so hopefully my messy writing will go away. So bear with it in this lesson and the next few lessons. All right, what is the meaning of all of these? Well, if you notice that each chart has time in minutes on the bottom, and on the side, it has all your marbles. And now that's just a fancy way of saying brain power. Like, how intelligent are you? Like, if you have a lot of marbles in your head, it means you got a lot of brains. If you don't have very many marbles, you don't have very many brains. So oftentimes people say, oh man, Mr. Croker's losing his marbles. That means he's going crazy, right? So let's take a look at what this means. Over time, the marble count is moving what? Up. So you're increasing your marbles. So you have an increase in brain capacity or brain power. That's a good thing. On this next one, over time in minutes, your marbles are what? Decreasing, they're going down, and you are losing your marbles. And that is known as a decrease. Your marbles are decreasing, and that is not good at all. The next one, over time in minutes, you can see that your marbles are staying exactly the same. They are not increasing, they're not losing. You're not losing brain power, you're not increasing brain power. You are just normal. Okay, so that one we say there is no change or zero change. And this last one is very unusual. At this moment in time, in minutes, let's say that that's 5 minutes or so. If it doesn't increase in time at all, but it is increasing in marbles. So how would you talk about this? Well, all your marbles are either down here, 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 here all the way up through there. Your marbles are all over the place at the same exact moment in your brain. Well, you might say, well, how is that possible? It's not. You're either losing your marbles or gaining marbles or staying flat or zero marbles, but you can't be everywhere. You can't be like, well, I don't have any marbles, and at the same time, I have plenty of marbles. It's just not possible. And this would be known as not a function. And you learned about the vertical line test in recent lessons. All right. What do we learn from this? Well, let's look over here real quick before we move on. Non-constant examples. We just got a whole length of constant examples, and these are non-constant. You can see that this one is crooked. Okay, so your marbles are changing rates. Okay, you got a steep rate right here, and then it comes down here, and then it increases again right here. Those rates are changing, so you do not have a constant rate. It is non-constant. Another form of non-constant would be this curve right here. You're starting here, but it's not consistent. It's rising quickly, and it's changing. So that is a non-constant example. All right. This next section right here says a very crafty word. It says linear, and the word line is underlined very specifically because lines in geometry or math are perfectly straight. And so we see that the rate of change is the same, or also known as equivalent. Now, another name for equivalent would be the constant rate of change. And that's what we're studying in this lesson, constant rate of change. Now, let's take a look at this next portion. It says how to find the rate of change. We know what rate of change is now. We just want to find out how to find it in a table. Okay, but before we begin these tables, if you scan through them, you can see that there's an X here and the Y is here. The X is here, the Y is here. The X is here, the Y is there. The X is here and the Y is there. So in all situations, you can see that the X value comes first. And that's what I want you to notice. Let's put that in our notes. The X values are listed first. Now, I can't guarantee this on all tables you'll ever see, because we have seen some in the past where the Y is on top or listed first, then the X. But most of the time, usually the X values are listed first in tables. All right, so what do we do with tables? Well, we look at these tables and we say, what is the difference between 2 and 4? So I'll make an arrow like that. And the difference is we are adding 2. And down below here, what is the difference of the Y values? 12 to 24 is we are adding 12. On the next one, we'll look again. What's the difference between 4 and 6? It's plus 2. And 24 to 36, again, is plus 12. Then we'll do another one. 6 to 8 is another plus 2. And 36 to 48 is another plus 12. Then we'll do another one. 8 plus, or 4 is 12. And then down here, 48 to 72 is 24. Doing some mental math there. Okay, and then the last one from here to here is a difference of 3 plus 3, and then down here the difference is 18. So plus 18. Now you see some fluctuations there in our comparisons, but this is how you find the constant rate of change. Go in the margin over here, and you can see that the triangle right here, that triangle means something. It is a mathematical symbol for the word delta. That symbol means delta. And delta means the change, means change. So it's the difference. So the delta y means the change in y, and the delta x means the change in x. So you can see that we're dividing the change in y divided by the change in x. And that's what we just found in our tables right here. In orange, we can see that the change in y is on the bottom right here. That's going to go on top. So we do 12 divided by the change in x, which is 2. And 12 divided by 2 is 6. And you can see if we did the purple ones here, it'd be 12 divided by 2, which is also 6. And then the red ones, 12 divided by 2 is also 6. And now we get to the black ones, and that's different numbers. So we'll do 24 divided by 4. So I'll do 24 divided by 4, and that is also 6. And then I'll go on to the yellow ones. And the yellow ones are 18 divided by 3. So I'll just type it, or write it, 18 divided by 3, and that is also 6. So in every situation, all the changes right here, the constant rate of change is always 6. So we can say, yes, this table has a constant rate of change, and it is 6. Let's try it again. Here, on the first one, we have a difference of plus 2 and a difference of plus 2. Then we have a difference of plus 4 and a difference of plus 4. And then we have a difference of plus 10 and a difference of plus 10. Then we go to the next one, a difference of plus 34 and a difference of plus 34. And finally, the last one, a difference of plus 1 and a difference of plus 1. And so remember what we do to find out if it has a constant rate of change. We simply do delta y, that means the change in y, divided by delta x, the change in x. So let's begin here. Let's do our red ones first. And our red ones are 2 divided by 2. Remember, y's go on top. So 2 divided by 2 is 1. Then we have another set of number here. We have 4. So we'll try those. 4 divided by 4 is also 1. Sorry about the ink drag there. It's the pen. Then we'll do another set of numbers. 10 divided by 10 is 1. And you can see 34 divided by 34 is going to be 1, and 1 divided by 1 is also 1. And so therefore, the constant rate of change is definitely 1. All right, let's try another. Number 3. The difference between 2 and 3 is 1, so we can put plus 1. And the difference between 18 and 16, now we're going down, so we say minus 2, or we can say negative 2. Either way, it works. The next one, The difference between 3 and 4 is plus 1, and the difference between 16 and 14 is, again, negative 2. The difference between 4 and 5/10 is positive 5/10, and the difference between 14 and 13 is is negative 1. And then the difference between 4 and 5/10 to 6 and 5/10 is positive 2. And the difference between 13 to 9 is negative 4. And finally, the last one, the difference between 6 and 5/10 to 10 and 5/10 is plus 4, or positive 4. And the difference between 9 and 1 is negative 8. All right, now, to check to see that has a constant rate of change, again, we do delta y, which is change in y, over delta x, which is change in x. All right, so we'll start with the red ones here. And remember, we always want to put our y's over our x's. So this should be written as negative 2 divided by 1 is negative 2. Then we'll do another number that's different. This is the same number, so we already know what that equals. We'll go down to the orange ones here and go negative 1 divided by 5/10. So negative 1 divided by 5/10. If you put that in your calculator, you'll actually see negative 2 come out. And then we move on to the next different numbers. These are different. Negative 4 divided by 2. That's negative 4 divided by 2, and that is also negative 2. And then the last one, we got to check them all, is negative 8 divided by 4. That's negative 8 divided by 4, and that is also negative 2. And you can see that across the board here, no matter what the change is, they are constant. So our constant rate of change here is negative 2. So we just did 3 horizontal tables, and now we're looking at a vertical table. And the x's are listed first. And so what we do is we go from 5 to 7, and we find out what the difference is. That is a difference of 12. And the difference between 10 to 10 is 0. We go down to the next one. The difference between 7 and 19 is 2. And the difference from 10 to 10 is, again, 0. And then the difference between 19 and 8.5 is 9, or no, negative, negative 9.5. And the difference between 10 and 10 is, again, 0. And all we have to do is remember to do our delta y divided by our delta x, and that's the change in y over the change in x. So let's start with our red ones here. Our change in y is 0, and we're going to divide it by 12. So we'll set that up. 0 divided by 12 is 0. All right, and then we'll go to the next one. 0 divided by 2 is 0. And then the last one, 0 divided by 9.5, or negative 9.5. 0 divided by negative 9.5 is also 0. And you can see that we have a constant rate of change. It is 0. And in fact, we have a class correction right here on this one. Someone raise their hand and help me out. So it's not 9.5, it's actually negative 10.5. So that's incorrect. And so we want to make this negative 10.5, which is still 0. So that worked out, luckily. Thanks for correcting me. Appreciate it. All right. So all of these are zeros. And in fact, if you look at this one, this is 0 slope. Have you ever seen the 0 up above? Well, according to marbles, we would have a flat line. And that's what that would look like when you have 0 as your constant rate of change. All right, so now you have observed how to find the constant rate of change when you have tables. And now we have this part right here. It says, do you have what it takes yet? And when we say yet, that's the growth mindset. And I'll give you a little warning here. One of these three tables, one of them, does not have a constant rate of change. So pause the video and try them out now. Pause now. All right, I got all three done. So number 5 and 7 have a constant rate of change. 5 was -2 and 7 was 3. Now, number 6 does not have a constant rate of change, which really is showing you right here. You had a 2 one time, then you had a 9/4. That's 18/8 reduced. And then you had a 2. They're not all the same, so they are not constant, which really just puts together which one comes first, the chicken or the egg. All right, moving on. On number 8, we are going to connect tables to sets of ordered pairs and graphs with linear relationships. And so this one's set up so you can see the how they relate to each other. All right, number 8, we have a nice table here, and we would naturally do something like this to find the constant rate of change, to see if it even has one. But we're not going to do that this time. We're going to make ordered pairs from the table. So our first ordered pair is parentheses 0, 10. Our next one is 1, 30. Our next one is 2, 50. And our last one is 3, 70. And those are our 4 ordered pairs. Then it says label the axes and units accordingly. So here is your graph. And looks to me, since we have a 0, 1, 2, and 3 with our x coordinates, we can carefully label our axes x and label it as 1, 2, 3, and 4. And that will work out just fine for the coordinates that we have. However, the y coordinates are multiples of 10, 10, 30, 50, 70. And so if we label these by 1, we will never even make it. So let's label them by 10s. So we're going to go 10, 20, 30, 40, all the way up. And now we're going to graph these points. There's 0, 10, 130, 250, and 370. Now you use your ID card or possibly something with a straight edge, and you draw a straight line connecting all of these dots. Let me try that again. Put a little arrow at the top. And you can see a straight line covers all of your points on the graph. And when that happens, you know that you have a constant rate of change. And in fact, this constant rate of change is positive. You are gaining your marbles. Whoops. All right. All right, so that's the graph. That's what it looks like after you graph them. So then you don't need to do this little arrow thing on the chart over here anymore, because you have a graph, and the graph is going to help you see that you have a constant rate of change. Now, going over to this last one, you've seen this before. This is delta y over delta x, and that just means change in y divided by change in x. And so what are we doing with this now? Well, I'd like you to pick 2 points. Pick this one and this one. And we're going to find out what the change in y is. So let's start at the bottom one right here. And we have to go up 1, 2, but that's not 2, that's actually 20. So since you're going up, it's a positive 20. That's my change in y. So I'll put 20 on top. And now what is my change in x? Well, my change in x is going to go to the right, and going on right on a coordinate plane is positive as well. And that is positive 1. So 20 divided by 1 is actually 20. And so our constant rate of change is 20. Now, I chose those 2 points, but you could choose different 2 points. Let's choose this top one and this very bottom one right here. Now let's go in a different direction just to see if it makes a difference. So we'll start here, and we're going to go over 1, 2, 3. Now that's the change, disregard the little arrow sign right there. That's the change in x, and that is plus 3 because we went to the right. Remember, don't look at the arrow sign. I don't know how that happened. All right, and then from there, we are going to move up, and moving up, we're going to go 10, 20, 30, 40, 50, 60. So that's positive because we went up. And now we put the change in y, which is 60, over the change in x, which is 3. And you can see again, 60 divided by 3 is 20. And so you can see that the constant rate of change is always 20, no matter what points you choose to find that constant rate of change. All right, so what have we learned? Compare the table to the graph. What similarities with the constant rate of change are observed? Compare the table, here's your table, to the graph right here. What similarities do you see? Well, the rate of change is the same. So we'll say rate of change, let's say, is constant. What's something else that we see? We see ordered pairs from both. Ordered pairs can be done from either one, the graph or the table. And now your question is, from which source is it easiest to determine the rate and if it is constant? Now, when you look at the table, can you right away see it's a constant rate of change? No, you got to do some math. But can you see on a graph if it's instantly a constant rate of change? You sure can. It's a straight line, and that means it is a constant rate of change. So I would say that the best way to do this is the graph. All right, so we just finished learning about the constant rate of change, and now we're going to learn all about slope and how to find it in a linear relationship on a graph. So I want you to plot the points for number 9 on the graph. And so plot them carefully. The R point is -1, 0, so -1, 0. S point is 3, 8, 3 all the way up to 8. Let's label them as we do them. So this was S. This was R. Label or find T, 0, 2. T. And U is -6, oh, sorry, went the wrong way. -6, -10, way down here. All right. Then you take your ID card or a straight edge and you see if they all line up. And they actually do. So you draw your straight line right over the top of them. And use a straight edge. I don't have a straight edge for drawing on the screen here. Oh, there's one. There it is. They all line up. That's good. So that means it has a constant rate of change. And it has a slope. And the type of slope that you're looking at is right from the very beginning of the notes. And this is known as a what? Positive slope. That is terrible writing, thanks to my pen. Positive slope. All right, well, what is the slope? To find the slope, all you need is 2 points anywhere along the line. I suggest picking points that are very close to each other. It's less work. Now, to find a slope, all you have to do is what you've already been doing. Find the change in y divided by the change in x. And the change in y up here, if you go from this slope up, you go up 1, 2. That is a positive, so it's positive 1. So my change in y is 1. And then I go to the right, and right on a coordinate plane is positive 1. Oh, I see I made a mistake here. The y change is not positive 1, it is positive 2. So let me make sure I fix that. Oops, not that. 2, might be confusing people watching this here. Let's do this again. 1, 2, that's positive 2. My pen's freaking out there. To the right is positive 1. So 2 divided by 1 is 2. Now, it wouldn't matter what 2 points I use. I could use any 2 points along this whole line. And in fact, just to prove the point, we're going to choose these 2 points, which are very far from each other, and it's not fun to use. So let's go ahead and start here. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's positive 18. And then we're going to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9. And remember, we put the change in y on top and the change in x on the bottom. And 18 divided by 9 is also 2. In fact, if you did the opposite, watch what happens. Let's say we choose this top point here and this R point right here. And let's say we started at the top. Watch what happens. We're going to start here and count down. 1, 2, oops, that didn't work. Try it again. Hold on, the pen is out of ink now. 1 second. All right, pen is charged. So we're going to start at this top one. We're going to go down. 1, 2, 3, 4, 5, 6, 7, 8. Now we're going down on the coordinate plane. That would be negative 8. That's the change in why we went down, so it's negative. And we're going to the left, so that's also negative. We went over 1, 2, 3, 4. That is negative 4. So all you do is a change in y, which is negative 8, divided by the change in x, which is negative 4. And you can see that a negative divided by a negative is also a positive. And so the slope, no matter where you do it along the line, is always 2, which is also the constant rate of change. All right. Now, I would like you to pause the video and do number 10. Pause now. All right, this is a nice flat slope right here. And we know at the top of our notes that this is known as a 0 slope because it's flat. All right, now how do you find your slope? Well, this is pretty easy. Remember, try to choose points that are super close to each other because you'll have less work to do, less counting. So if I'm going from M to M, do I go up or do I go down? I don't go up or down, so the difference is 0. That's the difference in y. Remember, I'm looking for the delta of y over the delta of x. And the delta of y is 0, and now I move over 1, and that's positive 1, so I put the change in x is 1. 0 divided by 1 is 0. And it doesn't matter what points I choose, I will always get a change of 0 over some sort of change in x. And no matter what it is, it will always be 0. So my slope is 0, and that makes a lot of sense because my slope is 0. All right, now it's time for number 11. Pause the video and plot 11. All right, it drew it all out, and this is definitely a negative slope, just like the very beginning of our notes say it is. And I already chose B and D to find the slope. So I started at D right here. And then I counted to the left, which is a negative direction. So 1, 2, 3, 4, 5, that's negative 5. And I went up 2. So my change in y is 2, and my change in x is negative 5. And 2 divided by negative 5 is negative 2/5. Now that's my slope, negative 2/5. I can easily choose two different points. Let's say I choose A and D. And I could start at D. It really doesn't matter where you start. So I start at D and I go 1, 2, 3, 4, 5. That's a positive 5. And then I go down, which is a negative 2. Well, then I still do my change in y, which is negative 2, divided by a positive y. And you can see it's still negative 2/5. So it really doesn't matter where you start or what point you choose, the slope will come out the same because there is a constant rate of change. All right, number 12, pause the video and try it. Pause now. Okay, here you can see that we have a vertical line. It is linear and it is undefined. So it's not positive, it's not negative, and it's not 0. It is undefined, it is vertical. And on this one, you can see that the slope is also undefined because if you check your rise over your run, the difference in y over the difference in x, you can see it's 3, like I have here. 3 divided by 0 is actually undefined. Your calculator will not do it. A lot of students are saying that any number, such as like g to I, that'd be a 1, 2, 3, 4, 5, divided by 0, a lot of students will say, well, that's 0. It's not. It is undefined. All right, so that's how slopes work when you're on a graph. But how do slopes work when you are dealing with only 2 coordinates? And I want you to notice here before we start, 13, 14, 15, and 16 have all the exact same points. And over here in your margin, it says m is equal to y subscript 2 minus y subscript 1 divided by x subscript 2 minus x subscript 1. Now, you've never heard of subscripts before in math. Those are not exponents. Those are subscripts. And this m right here stands for, in mathematics, the word slope. And it's kind of easy to remember because mountains have lots of slopes, and m is the beginning of a mountain. So that might help you. Now, what do these little subscripts mean? Okay, well, this little subscript right here means the second y and the second x, and this one means the first y and the first x. Okay, so how do you use those? Well, you go over to number 13, and you have point A and point B. And so we know that the slope of these, which I'm using it directly from our last one, negative 2/5, same exact points, but we're going to label these as the first point and the second point. Remember I said you can use any 2 points to find it? All right. And that means that this is your x, and this is your y, and that's your x and your y. Now what you're going to do here is you're going to make a nice division bar. And of course, this is equal to m. We have a subtraction sign here and a subtraction sign here. We're going to use the substitution property. So we're going to build our parentheses for all of our numbers we're going to insert. And then we're going to start filling it in. And the very top left, if you look back over here, it's y subscript 2. That means the second y goes in that spot. Well, the second number in our case, the second y is right here, -2. So we'll put a -2 right there. Right below it is supposed to be the second x. Well, where's the second x located? And the second number right here, it's -4. So you'll be very careful that you do not mix these up. Now we're going to go for the other one. This is the first y goes up at the top because that's where it says it over there. So we'll put -6 up here. And then that's the first x, and that goes down here. Okay, now time to do the math from Unit 1. So we have subtraction sign going up here, so we're going to use additive inverse and additive inverse, and now we will do the math. -2 plus 6 is 4. -4 plus -6 is -10. 4 over 10, or -4/10 can be reduced down to -2/5. See how that comes out? And that is definitely a thumbs up. Now, in the lesson, I told you it doesn't matter what 2 points you use, you can always find the slope. And that's what number 14 is all about. Let's switch these and now say that this is our second number, and this is now our first point, or second point and first point. Definitely switched them. And now let's draw out our bar with our minus signs. Put your parentheses there and start filling in things very carefully. So we can see that this is an x here, and this is a y. Those are our second numbers. So our second numbers go first. Remember the formula? Okay, our second numbers go first. So we're going to go -6 and 6. Now those change positions from number 13. They're in the front now. And let's put our first numbers in the back. And that's going to be -2 and -4. And we're going to use additive inverse on both. Now, if we do our math straight across, -6 plus 2 is actually -4. And 6 plus 4 is actually 10. And that simplified is -2/5 again. So you can see it doesn't matter which 2 points you use, you just got to make sure you're putting them in the right positions. If you don't, this is what's going to happen to you. A thumbs down. Let's mix it up. Let's put our first, let's call this first. Get organized here. First and second. Let's put our first y in the wrong spot. So that's going to go here. Let's put our second y in the wrong spot right there. Then let's go and put our first x in the correct spot and put our second x in the correct spot. So the bottom ones are right, but the top ones aren't. And what happens? Well, we're going to use additive inverse and additive inverse, and we'll just do the math here. -6 plus 2 is -4. And -4 plus -6 is -10. Well, a negative divided by a negative is actually a positive 2/5. See that? That is no good because it is a negative slope and we got a positive value. So that's a big indicator that we messed something up big time. Now number 16 is here just to do another bummer one. And I think you guys understand what bummer ones are. So we're going to write skip in this spot for your notes. All right, that does it for the lesson. Now you're going to put your first name, last name, date, and period. And I'm going to do some odds here with you. On the first one, it says, find the constant rate of change between the quantities in the table. And remember, you just learned how to do this. We got to find the change in y's. So that's +5, +5, and +5. And on the bottom, we are +60, +60, and again, +60. This one's really easy. They're all the same. They're not any different. And so you take your change in y, delta y over delta x, and you get 60 divided by 5, which is 15. So your constant rate of change is 15. Am I wrong? Oh, it's 12. Thanks, class. I'm wrong. It is 12. 12. My mental math was not working there. All right, moving on to number 3. Find the constant rate of change for each linear function and interpret its meaning. So you may not be able to see, but if I blow this up in blue, you can see that there are points already listed here for you. And all you need is 2 points. So we like choosing points that are close together. None of these are any different than any others. So I'm going to start at 1 and go up. I'm going to go up. Oh, so I got to notice here that these are by 2s. I would have gotten that wrong. So that's 2 and 4. That's +4. And then I'm going to go to the left. What are these valued at? Well, from here to here is 4. That's 8. So those are by 4s. So I'm going to go 4, 8, and I'm going left. So that's a -8. And all I have to do is do my delta y divided by my delta x. And I get 4 divided by -8, which is -½ And that is my constant rate of change. So be very careful. You're paying attention to the numbers, the units that the graphs are using, or else you could get it wrong. And then number 5 is finding the slope of each line. And all you have to do is the same thing we just did. You need 2 points here and here. And these are by 1s. So we're going to go to the right, which is +1, and then up 1, 2, 3. So positive, positive, delta over delta, delta y over delta x. And that is 3 divided by 1, which is 3. And it does not matter which point you use, you'll find the right answer. That was from a graph, just counting. Now they give you points. And in the points, you have to remember that you are using y subscript 2 minus y subscript 1 divided by x subscript 2 minus x subscript 1. That gives you m, and m is the slope. So on number 7, this is my x, this is my y, x and y. I'm going to call this my first point, and this is my second point. Okay, being very careful to set this up correctly with my parentheses. And I want to put my y's on top, but I want my 2 to be first. So -3, and then 8. And then my 4 is my 2 first, 4 and 3. Remember, it doesn't matter which one you label as 1 or 2, 2 or 1, it does not matter. So then we go to additive inverse, and additive inverse, and we get -11 over +1, and -11 divided by 1 is -11. That's my slope. And that is how you do the work. All right. The class member saved you on number 4. They want to know, how do you do this one? Well, you need some points, and there's no points, but a point is where the line crosses intersections. So you can see there are 5 points to choose from. So if a line does not have points, you can see where it crosses intersections on the graph, and that is how you find it.